Hi, everyone. Unfortunately, Voja Antonic is sick, so Mike Szczys is going to present Hacking the Badge instead. So please welcome to the stage the managing editor of Hackaday.com. Mike is a musician by day a musician by night, and and works on Hackaday during the day. Please welcome Mike.
Can I move around with this mic? That is the question. So I've been watching the animations that go by, the generative animations. They're really awesome. Have you noticed these? So Alexander Bredish in the back there did all the animations. And I don't know, is Rich Hogben in the room? So the music is actually Rich Hogben, who's was in charge of cinematography for the Hackaday Prize video and works the Supply Frame office in San Francisco. So really fun stuff. Right here, there you go. So like Sophie said, I am not Voja Antonic. My name is Mike Szczys. I worked a little bit with Voja on getting the badges ready for badge hacking, and we're really excited to have a piece of hardware for you to have your hands on. And Voja seemed to find just the perfect set of parameters for this piece of hardware so that everyone, no matter your experience level or your interests, can really take it and run with it. The first thing that I'd like to mention is the design. Just the look and the feel and the shape and the function of it is brilliant. It's really a piece of art, and I guess at face value it's a bare PCB, but you would ruin it by putting it in a case. It's beautiful for what it is right now, and even I didn't think it could get better from the time that we had the prototype till now, but some things changed a little bit. So we had a glossy black finish before, and this matte black finish is much better. I really like it how the silk screen that says Hackaday SuperConference on the front matches kind of with the color of the LEDs when they're all off. And the reset button and the power button used to be red in the prototype, and they got changed to this color. I think it really ties it together. If you look at the badge from the side, the fact that he has these through-hole battery holders that are mounted on the edge, it really cuts down on the apparent thickness of the badge because you're kind of splitting the difference there. And I think another nice aesthetic to it that you don't notice is right off is that the board is cut out just a little bit so that the amount that the batteries stick off as wings is also kind of pushed in. And it's just an amazing piece of design. You add into it the 45-degree cutouts and how they're laid out and the ratios there, and I can't think that this could be any better than it is. Voja, although he has lost his voice, is in the front row, and I'd just like to recognize all the work that he did on this and give him a hand right now. All right, so I do have some slides, and these slides are all about hacking the badge and everything that you need to make that happen. All right, so hacking the SuperCon badge. If you have never before touched a piece of hardware, you can make this badge do something. So I would say figure out how to turn a light on or turn a light off. It's an amazing thing. That's kind of a cliche, right, with Hackaday, right? Like I made it blink, I made a blinky, but there's big power in that. So if you've never done anything with hardware before, set that as your goal. We have a C framework that is all set to go. Basically, you can go and turn a 0 to a 1 in a specific place, or a 1 to a 0, and that either lights up or turns off an LED. Ask anyone here. They'd be happy to help walk you through this. Now, if you are a seasoned veteran and you know how to write machine code and you want to get really close to it, you can do that as well. So let's dive right in. These are the addresses that you might want to take note of, so I'll go ahead and pause there for a second. So the first one is a page that Voja put up that has pretty much all of the information that's in this talk is there, so you can go back and reference it again. It's got the schematic, it has the files, it has the compiled demo that came with your badge, it has links to the crypto challenge, so you can flash what you got the badge with, you can get back to stock, you can put your own code on, you can do the code challenge. The other one is the C framework. This is just a quick IDE project that you can unzip that does shows you how to do button input and how to change things on the display and read from the accelerometers. Here is the schematic. Is there a laser pointer? No laser pointer? All right. What? Oh, cursor? Oh, look at that. There's a cursor. Excellent. All right, so this is the chip right here. It's a PIC 18LF 25K50 that has USB functionality on it. Thank you, Chris Gamble. All right, so this has USB functionality on it. And so in order to program your badge, you do not need a proper programmer. You can use one if you want to, but there's a bootloader on it. And Garrett Scott and his colleagues over at Microchip did a bunch of stuff to help us get this new bootloader, which enumerates as a USB thumb drive. So when you plug in USB to your badge, you can hold down the power button and press reset, and that'll put it in bootloader mode. You'll have an LED that will start blinking. The badge will appear as a thumb drive on your computer, and you can just copy a compiled hex file onto it. And then press the power button to run your user code. So once you're hacking on the badge, you don't need to unplug your USB until you're all done with your hacking. You can just power reset to get into bootloader mode, and then power to start running the user code. I do want to go over hardware, though, for those people that are doing the hardware hacking challenges. So the nice thing is the bootloader handles all this stuff. So I'll go over it kind of quickly. But what Voja has set up is an LED row driver right here. So it's got 16 lines. That's getting shifted in through this data line and this clock line. And on the high side, he's got MOSFETs to turn it on. So you're only turning on a few LEDs at once. And this is a demultiplexer decoder. It's a decoder chip right here. So he's getting these 3 lines to help decode that stuff. One of the reasons you might want to go with the bootloader is that it handles some stuff that is kind of tricky. So for instance, if you look at these lines for the buttons, they are kind of shared up onto the decoder line, so there's some trickiness going on in there, but Voja has written about that, so if you want to get elbow deep or shoulder deep or worse, check that out. A new thing with the badge here is this breakout header, so it's on the back, and it's not populated, but we do have headers in the badge hacking area, so you can solder on pin headers, and then there are connectors there available as well. There are 5 general purpose I/O pins right here, and then 2 ground and 2 voltage. Also on this chip is an accelerometer, which is just connected to with 2 pins. This up on the top right here is the infrared communication. We're going to go over that in a bit. And this is the programming header right here in the USB. Yeah, I think that pretty much takes care of it. Excellent. All right, so let's jump in. In the C framework, there is a memory map. So all the stuff that I'm about to go over has like register numbers. You can look up all those numbers in this file, which I should have put the file name in there, but it's called hadbadge.h. There's only a couple of header files in there. And some of the stuff that we're going to be talking about, for instance, like the buffer to write to the screen. So this is 16 rows of 8 bits, which represents the 16 rows on your badge right there. Let me go over some of the things that the badge has in the stock firmware. So how many times today did you hear someone pick up their badge for the first time and go, oh, it has Tetris, neat. I must have heard that about 30 times today. I think it's one of the most popular things. So something interesting with Tetris is when you press the power button, it actually goes into a pause mode. So there is a pause buffer. We'll talk about that in a sec. Push it again, it goes into low power sleep mode. I actually had my batteries in the Belgrade badge since April, and they still worked when I pulled it out to start with this. So the low power sleep mode is really good. The board has an accelerometer. And accelerometers, I was confusing accelerometers with gyroscopes on the way that they work. So the accelerometers is like having springs that can detect which way the badge is pulling on those springs. So it's not really like twisting. I thought it was into twisting. So at any rate, play around with that. The interesting thing here that I didn't find out myself, but Voja told me, is that he built dice into it. So while it's doing this, if you shake it, you're going to get random numbers. And there is a random number generator on there, so if you're doing games, you can use his random number generator that he has built in. The top button has displaying message, and you can actually change this message using the infrared. There is a terminal computer to program the badge. Is that in the badge hacking area? Yeah, so you can go and write your own messages, and you can tell it what font and which way to scroll and all that stuff. We'll go over that in a second, how that works. And the last one is The bottom button gives you your serial number, which is kind of the key for your badge to get infrared communication so that somebody doesn't, spam your badge with their own messages. As far as programming this, the buffer, which is again in that memory map, but it's also at address X700, it has a little translation. Any 1 is an on, any 0 is an off, and you basically write into this, and you're going to have the badge display it. There is another frame buffer, which is used for the pause mode. So when you see the pause mode in Tetris and it gives you your current score, that's the other buffer showing up. So you can use that if you want to have 2 buffers. It's available. There is quite a bit of information up here. I think probably the most interesting, if you're going to do kind of medium to low level hacking, is on this flag register, looking at the handshaking. Bits 1 and 0 here are tied into Voja's scanning interrupts. So you can do pretty accurate timing that way, and it's already running. So you just need to check for those flags and then clear them once you've read them in order to get good timing. The key edge is another one. So this key edge register allows you to read bits 0 through 4 to see if the keys have been pressed. And again, you need to clear that bit after you've read it. So you basically check, has the up button been pushed? Yes, it has. All right, set that back to 0. And then the kernel that's running in the bootloader space will load that up again. This is a diagram of program memory. Grab my laser pointer here. Oh, I'm totally going to get this wrong. All right, so we start at the reset vector, and we go through our interrupts, which somehow end up right here in user code. And so if you look at the C framework for this, you need to handle the interrupts by sending them back to these addresses in the bootloader. Did I get that almost right? And so if you do want to completely bypass the bootloader and do all of your own hardware stuff, you just don't send those interrupts back. You use those interrupts for whatever you want to use them for. But in this case, if you look at the C framework, it's already set up so that when your interrupts happen, you can put code here if you want to. Watch out, because you might mess up the display timing. One of the other features of the badge is dimming mode. So if you hold both left and right and then repeatedly press down, your badge will get dimmer. Or if you repeatedly press up, your badge will get brighter. And this is also something that you can affect in your user code. It's in the memory map as well. So if you want to make a game where the better you do, the brighter the display gets, or the closer the fireball gets, you can change the global brightness of the display, which is pretty neat. But if you're putting code in your interrupts here, you might mess up the timing for that dimming. So watch out for that. If you see weird behavior, that's probably what it is. I know because I caused that in my user code, and it was unfortunate in Belgrade, but we fixed it now. As for everything else, running a loop in your own code, that's all going to run just fine. The bootloader won't really interfere with it other than stealing a few cycles when it goes to service all of the hardware. I'm actually going to just go past this one. I kind of went through this on keys. Dig in if you want. Again, in the C framework, it shows you how to check that bit and clear it. This is the timing that I was talking about, so you can check this flag register, and you get your 1200 hertz or your 150 hertz on these. And it's just basically wait until one of these is set, do your code, and then reset. It's kind of like software interrupts. It's your software latching onto those interrupts to synchronize with what the bootloader is doing. I think this one's pretty interesting for anyone that wants to do some communications with their badges. So basically all you have to do is wait until this bit is set. So that would be the badge saying, hey, I'm ready to transmit some data. And once you see that, you can use this register right here. Again, it's memory mapped. Put your data in there, and then the badge will go ahead and write it out. It'll find that there's data there ready to be sent, and it'll send it, and then it'll write to this again. So you can just put a loop that says check for this until it is 1, and then put your data in there, and then do you have to unset this? Do you have to unset this bit? Okay, all right. Okay, excellent. All right. And the next one's going to be receiving. So receiving is a little bit, it's kind of the same. So you want to watch this bit right here. So you want to set this bit to 0. Yes, okay, you want to set this bit to 0, which says receive, and you want to wait until the flag is set, which means there's a message for you to read. It reads it into this data space, again, that's memory mapped, and you can pull that out. An interesting thing is that there is a length to the string that you can have, but also there's a header. So that's where the number of the badge comes in. So from the stock firmware, when you go down, it gives me badge number 170. My badge is only going to listen to a message that has a header that has that number. And so the station that Voja has set up to write a new message to your badge, it asks for your serial number so that it can add that to the header. So if you do want to do any bidirectional communication, watch out for that header because that's how the bootloader runs it. And then ending is really simple. You just have to pause longer than 200 milliseconds, and then it assumes that it got the full message. And all this stuff is handled automatically in the bootloader, so you don't have to worry about. Actually, this one's handled in hardware because it's a transceiver module, so you don't have to worry about decoding the message itself. You just get something in memory that you can read off, which is nice. So I talked about pause mode a little bit before. I think I'm going to skip by that one. This is really interesting. So the accelerometer is fun to play with, and you can do something really simple or something really clever. Like I think the shaking is really clever for this badge because it's very easy to see that the shaking is distinct. Like if you don't do it quite right, it doesn't come on, and that's good behavior. And the way that Voja is doing that is having the bootloader write to these 16-bit variables. Now, the least significant nibble of the lower bit is empty. And then we start with the least significant values. And so you get a 12-bit value, but the bottom 2 bits are really noisy. That's the 0 through 4. Do I have that right? 0 through 3. And so you can actually just leave those bits off. And in my testing, I just read the top one, and for my, for my use of just being like, are you tilting one way or the other? It was perfectly fine. So play around with that a bit. One of the things I thought was interesting is I just mapped all 6 of these to the display and then played around with it for a while. So you can kind of do your prototyping by just like what LEDs are lit up, and that's pretty fun. There's a function call, so you need to do, I did an assembly goto command. You can see it in the C framework, and I actually wrapped it in something, so you can just call a C function. But you just basically say, hey, go out and run this subroutine. It's going to pull over those 2 lines for the accelerometer, dump this into memory, and then you can read it out and do what you want with it. The same is true for the pseudo-random number generator. So it's a subroutine in protected bootloader space. So all you have to do is make a call. Voja does have the timing here, so it's 79 cycles in order to do a call. I'm kind of a messy programmer, so I was like, I'll call that, and eventually it'll just be there. And so you have these addresses, X730 through X733, and I believe those are actually the seed values too. It overwrites the seed. Is that right? Yeah. So you're going to have, it's the same place. You can instantiate a seed if you want, or you can just go with what's there. But then you can read that out, and it's going to be your pseudo-random number. You get 32 bits. So if you're just doing simple game stuff and not cryptography in your badge, I would love it if somebody did crazy cryptography on their badge. So please do. Just as a straw poll here, has anybody here tried the crypto challenge yet? Have you flashed the crypto challenge? A couple people. Okay, if you have made it past at least one challenge, at least 2 challenges, solved 3 challenges, solved 4 challenges? No, not yet. So it looks like Rich is on number 4 right there. You can go and bribe him for hints if you want. Don't help him, Rich. And my advice too is, as you solve those, write down your answers, because otherwise you're not going to want to flash a hacked firmware on your badge, because you'll be like, I'm doing the challenges. But super fun there. All right, what else do we have left? Oh, so for the super crazy embedded people who want to get really close to the metal, this can be programmed with a pick kit, and I actually have one if you want to borrow it. I'm guessing we have some in the badge hacking area as well. But you are going to be, setting up all of the hardware servicing stuff that's in the bootloader. If you blow that out, you're going to have to take care of that yourself. So good luck. I only know one person that did it. It was Mike Harrison of Mike's Electric Things. Mike's Electric Stuff. Which one is it? Stuff. Mike's Electric Stuff in Belgrade came and did 16 levels of grayscale and did all kinds of animations, and they were really cool. But he also worked on it for a few days before he got there. So challenge accepted. We'll be here late tonight. Please give that a try yourself. All right. And just to give you a little example of how the bootloader is actually working. So again, it's got this code that's running, and when it hits into bootloader mode, it takes what's coming over the USB and it puts it into this space starting at an offset of 0x3300. If you program with your own programmer, you're going to be blowing that bootloader out. So that's what this is showing. And again, it's just going to show you the animated GIF that's not animated, and the pages. This was showing the example of what the C framework is going to do, which it starts off with one pixel highlighted, and if you press the buttons, it moves that pixel around. There'll be two rows that are blinking at what is approximately 1 hertz. And then on the bottom, there's an arrow left or right. And so when you open up that framework, it's very simple. It just says, this is how you do non-blocking timing. This is how you read from the accelerometer. This is how you write to the display. And this is how you use buttons up, down, left, right. Anyone who's done any sort of programming can look at it and be like, this is simple. And that guy doesn't know what he's doing, which is fine because I don't. And then anybody who hasn't done it before, seriously, look to your left, look to your right. Both of those people would be happy to help you get your feet wet. If you haven't blinked an LED, you can't leave this weekend without doing it. I'll be at the door asking as you leave. All right, so one last time, I just want to say thank you so much to Voja for all of his work on this badge. I think it really makes the event special, and I know I've already wasted way too much of my time before we got here playing with this badge, and I'm going to stay here late tonight doing the same thing. So one more round of applause for Voja.
Thank you.